And there we go. All right, so day one of combinations. So first, again, right, we're starting with the permutation. I told you permutations, order matters. In a permutation, there's mention of place or position. It's more specific in its setup. A combination, order no longer matters. So we're looking at an arrangement of people, items, things, but order does not matter anymore. So I'm going to say an arrangement of people, items, things. I'll just say items. You guys get the idea. So an arrangement of items where order does not matter. So in a permutation, we get a lot of detail. We're told place or position. It's nice to have all those P's together. Permutation, place, position. Combination, it's more of a general grouping of people, items, things. All right, so combinations. Order no longer matters. We're looking at general broad groups of people, items, or things. All right, so first I'm going to show you the calculation. So instead of a P, we're going to see a C show up. So NCR or N choose R. Okay, N is our total items, whatever we're looking at. So the total number of items. Okay, and then R is the number of items of interest. All right, so when I work through my calculation, it starts off looking just like a permutation. So N factorial over N minus R factorial. That's what it would look like as a permutation. There's going to be one other detail I'm going to tuck in just a moment. So think about the letters for a moment, right? The first time I showed you that letters variation for a permutation, I showed you dad, right? And we had those two Ds. And if we flipped them, well, it looked exactly the same, right? So that idea translates to the combination as well. So if order doesn't matter, if I have a group of individuals A, B, and C, well, that's the same group as ACB or BCA or BAC or CBA or CAB. That's the same group of three people. So I divide out my duplicate groupings. So right here, I'm going to tuck in that little extra piece, R factorial. So this reads as your duplicate groupings. And then I'm just going to write that in words. So think of a combination as, well, it's just like a permutation. But we have to divide out those duplicate groupings. So for example, right, if I have group ABC, right, that is the same group as CAB. right? It's a duplicate. All right, so again, combination, just like a permutation, but since the order no longer matters, right? It doesn't matter how I pull them. So if I have a group of A, B, and C, it's the same group as CAB or BCA, etc. Those are duplicate groups of the same 3 people. All right, so here in example 1, I'm just going to do the calculations side by side. So find the number of permutations or combinations. Let me zoom in because I know those numbers are really small. So let me get a little tighter right here. And I left room for a reason. I want you to visualize it for this first example. So 5P2. So imagine I have, 5 kids in a class that are in a group, and I'm assigning 2 of them to a specific position. I'm saying, okay, you're my leader, you're my recorder. So 5P2. So if I'm calculating this longhand, I would say 5 factorial over 5 minus 2 factorial. So 5 factorial over 3 factorial. So when I multiply that out, it's like saying 5 times 4 times 3 factorial over 3 factorial. Right? I can write that out as 3, 2, 1, that's fine. I'm just using that 3 factorial as a time saver. So if I see 3 factorial over itself, that just reduces 1 to 1. So it's really just like 5 times 4. And that makes sense, right? I have 5 students who could be my leader. And once I filled that slot, now I have 4 that can be my recorder. So 5 times 4 would get me 20. Okay, but I left you room here for a reason. I wanted you to visualize what those different groupings could look like. So I could have person A as my leader, or B or C. I'm leaving space for a reason, or D or E. So all of those could be my leader, right? That first position that we're filling. And then if I pick A as my leader, then my recorder could be B, C, D, or E. But if I pick B as my leader, then my recorder could be A, C, D, or E. And if I pick C as my leader, then my recorder could be A, B, D, or E. If I pick D as my leader, my recorder could be A, B, C, or E. And then lastly, if E is my leader, then the recorder could be A, B, C, or D. So you can see the 20 different arrangements, right? Where order matters. There were 20 different possibilities that could shake out here. So what happens if I say, well, same idea. We have 5 kids in a group, and I'm picking 2 of them to make a little subgroup, but I'm not giving them a specific role. I'm just picking a subgroup of 2. So it's a general group of these 5 students, right? We're picking 2 from that group of 5. So here becomes a combination instead. So combination, we start off the same way. We say, okay, if it was a permutation, it would be 5 factorial over 5 minus 2 factorial. But since it's a combination, I have some duplicate groupings. So I have to divide out this 2 factorial. This is my duplicate groupings. And for example, group AB would be the same as BA, right? Same group. If I'm not assigning them to a certain role, a place, or position, right, it doesn't matter how I picked them, but student A and B Whether I pick them A, B, or B, A, it's the same group of two, right? So it's a duplicate grouping, just like the letters. So think of your combination as a permutation, just with duplicate groupings. All right, so if I keep working through, that's really 5 factorial over 2 factorial times 3 factorial, just like that. So I could say 5 times 4 times 3 factorial on top. 2 factorial is just 2 times 1. And then here's my 3 factorial just as a time saver. If I want to write it all out, that's fine. All right, whenever I have 3 factorial over itself, right, that's 1 to 1. And then I have to reduce down because I have a denominator with 2 in it, right? So if I look for my even number on top, I see the 4 here and the 2 here. So that can reduce to a 2 to 1 ratio, just like that. So really, that's going to simplify to be just 10. So if I make a list of what those 10 groupings would have to be, right, let me just go back to my list over here. Let me zoom out for a moment. So if I go back to here and I go, okay, well, I have group AB, AC, AD, and AE. There's 4 groups. BA, well, I already have that, right? Because that's the same as AB, right? That one's taken care of. That would be a duplicate. So a new one would be BC, and then BD, and BE. CA, do I already have that? Yeah, I already got that one because that's a duplicate with AC. CB, I already got that one too. That's a duplicate with BC right here. But I don't have CD yet or CE. Okay, moving up here, DA. Well, I got that one, right? Because that's the same as AD. DB, well, I got that too, right? That's the same as BD right here. DC, I got that also, right? That's covered for me right here. That's CD. So here, DE is my last one that's new. All of these ones here have already been covered, right? Here's EA is the same as AE. EB is the same as BE. EC is the same as CE. And ED is the same as DE, right? So I see my 10, right? I can see my 10 without any duplicates, right? Because we've divided out those duplicate groupings. It's just like the letters. All right, let me remind you how to do it in your calculator too. So in my calculator, if I type it in, let's say I do the permutation one first. So I'm going to type in 5 and then math over to probability. And I'm going to pick permutation. So that's second choice right here. And then 2. So I put my N and then I hit the NPR. And then how many am I looking for? I'm looking for 2. All right, so here it confirms that it's 20, but it's important to me that you know how to do it longhand, you know the mechanics of it, and the shortcut. So now if I say, okay, what if it was a combination? So 5, math, over to probability, but now I'm going down to that third choice, NCR or N choose R, and then I type in a 2, and I see 10 instead. Okay, so we should know how to type it into the calculator to get to the same calculations. All right, sliding on up. Do you guys have any questions so far? Okay. All right, so what is the difference between a permutation and a combination? So permutation, we know that order matters. Order matters. And for a combination, it does not. Order does not matter. Okay, when I'm trying to distinguish which one is which, for a permutation, it's more specific. There's more detail, specifically mention of place or position. So we're making people first, second place. We're giving them a specific role to fill. Leader, recorder, president, vice president, something along those lines. Okay, for a combination, right, the order doesn't matter. So it's much more general. There's less detail in the setup. And we're just looking at a general grouping. So we'll leave it as general right there. All right, so if I do ones side by side, here we have 10 friends and they enter an art contest. And I'm saying, well, how many ways can they receive awards for first, second, and third place versus 3 honorable mentions? So in scenario A, that is our permutation, right? It's what we've seen a lot. This one is a permutation, place or position. 3 honorable mentions, well, that's the same prize. So the order really doesn't matter, right? If I award that to students A, B, and C, it's the same as if I award it to BCA or CBA, etc. So this is our combination instead. All right, so if I solve the permutation, right, that's 10p3. So 10 factorial over 10 minus 3 factorial. And then that turns into 10 factorial over 7 factorial, or 10 times 9 times 8 times 7 factorial over 7 factorial. So the 7 factorials, right, they cancel away 1 to 1. And that makes sense because I have 10 friends, right, who could finish first. And then once first place is decided, now I have 9 that could be second, and then 8 that could be third. So it's really just 10 times 9 times 8, 720. And if I treat it as a combination, if I say, okay, we're not giving first, second, third, we're going to say just 3 honorable mentions. It's the same prize. It doesn't matter, you know, who got it in any order, right? Order doesn't matter anymore. So group ABC is the same as CBA, combination. Well, we have to solve for the permutation and then divide out those duplicate groupings. So 10, choose 3. So 10 factorial over 10 minus 3 factorial. That's how it looks, just like the permutation, but I have to divide out my duplicate groups of 3. So 3 factorial is that little extra piece. Okay, so now doing it longhand, I have 10 factorial on top over 3 factorial times 7 factorial. So 10 times 9 times 8 times 7 factorial. 3 times 2 times 1 times 7 factorial on the bottom. Let me get Ashley back in. There we go. All right, so the 7 factorials, they knock away 1 to 1. And then when I look at the other numbers on the bottom, I see a 3. So if I look up on top, is there anything divisible by 3? And there's the 9. So 9 divided by 3 is 3. So 3 to 1, just like that. And then with the 2, well, I could choose either the 10 or the 8. If I choose the 8, it reduces to 4 to 1, just like that. So I end up with 10 times 3 times 4, which is 120. And remember what I said, a combination is just a permutation with duplicate groupings. So it's like taking that 720 and dividing out the 3 factorial, which is 6. And 720 divided by 6 gets us to 120 right over here. All right, we still doing okay, you guys? Everyone hanging in there? Any questions? Okay, let's flip. All right, example 3. So you're gonna see a couple like these, and just heads up, what I wanna ask is I wanna ask F. So I wanna cut straight to the chase and I wanna get to F. This is my goal. But I'm going to show you how to get there and how to make sense of the problem and how we actually get to part F. All right, Lily. Lily's our key player for the day. So we got Lily. She says, Mom, can you make me a turkey sandwich? Her mom asks, well, what else do you want on this sandwich? She gives her the following options. You can have cheddar cheese. You can have salami. You can have lettuce. You can have pickles. So we have 4 additional toppings or ingredients, whatever you want to call them. I'll say toppings. We have 4 options. Okay. So we're told sometimes she likes that plain turkey sandwich, sometimes she likes all of the extras. So we know that really she could have none of the extras or all of them or something in between. So I've fleshed that out for us. I said could have none, could have all of them, or something in between. So what this really becomes is a combination, right? Because if I pick 2 things, let's say that it's salami lettuce, doesn't matter the order. I have salami and lettuce. It doesn't matter if I say lettuce salami, it's the same 2 toppings. So combination. So right here, this would be 4, choose 0. This would be 4, choose 1. 4, choose 2. 4, choose 3, and 4, choose 4. Okay, and I know we know how to do it by hand and in the calculator, but I want to point out something, an extra relationship. So let's say that I start with the 4, choose 0. So that's like saying 4 factorial over 4 minus 0 factorial with that extra 0 factorial for any duplicate groupings. So it ends up looking like 4 factorial over 0 factorial times 4 factorial. The numbers on the bottom, can you see how when you add them together, they make up what's on top, right? So 0, 4, I have 4 on the top, right? It makes sense. And if I work this out longhand, well, 0 factorial is always 1, and anything over itself is 1, right? So there's really just one plain old turkey sandwich. Right, so 0 additional toppings means she's getting a plain turkey sandwich. Let me write that here. So plain turkey, no extras. Plain old turkey sandwich. Okay, but how many ways could she get 1 additional topping? Well, whenever we have 4, choose 1, it ends up just being the n value. So I know right off the bat that it's going to be 4. But let me show you the mechanics. So I have 4 factorial over 4 minus 1 factorial, and then the duplicates, 1 factorial out in front. So here I have 4 factorial over 1 factorial times 3 factorial, like that. So if I work this out longhand, right, that's like saying 4 times 3 factorial. 1 factorial is just 1, and I still have that 3 factorial right there. So again, anything over itself is just 1. So here these cancel away 1 to 1. So I end up with just 4. All right, what if we have 2 additional toppings? So here I would have 4 factorial over 4 minus 2 factorial, and then the duplicates, 2 factorial out in front. So 4 factorial over 2 factorial times 2 factorial, just like that. So here I have 4 times 3 times 2 factorial. Well, 2 factorial is just 2 times 1. I'm just going to write it out like that. And then the other 2 factorial. The 2 factorial over itself will just go 1 to 1. And then if I look at, say, the 4 and the 2, That reduces to 2 and 1 just like that. So 2 times 3 gets me 6. All right, how about 3 additional toppings? And here I'm hoping you can see a pattern show up. So 4 factorial over 4 minus 3 factorial, and then my duplicates, 3 factorial right here. So I see 4 factorial over 3 factorial times 1 factorial. Well, isn't that the same as what we have right here? Right? Aren't those the same thing? Because the bottom is really the same. We just switched the order, right? So 1 factorial, 3 factorial, or 3 factorial, 1 factorial, it's the same bottom, right? It's the same denominator. So it ends up calculating the exact same way. We're going to get 4 right here. And if I have 4 choose 4, right? If I have 4 additional ingredients and I'm picking all of them, there's only one way that can shake out. But let me again show you the mechanics. So 4 factorial over 4 minus 4 factorial. And then the duplicates, 4 factorial right there. So I see 4 factorial over 4 factorial times 0 factorial, which is again just 1 right there. And I see, oh, it's the same exact calculation that I saw up here. Barbosa, I'm going to circle back. Just give me 1 second. So we end up getting 1 right here. All right, so what you might notice is it's like a numerical palindrome, right? It reads the same forwards and backwards. 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. So it ends up being this numerical palindrome. So one other thing I just want to point out too is that, let's say I gave you 10 choose 3. What would that be equivalent to? Right, we saw that these were equivalent, 4 choose 0 and 4 choose 4. We saw that these were equivalent, 4 choose 1 and 4 choose 3. So what's 10 choose 3 going to be equivalent to? It's going to be the same as 10 choose 7, right? Because it's just, what's 10 minus 3? 7, right? If I showed you longhand, this would be like saying 10 factorial over 3 factorial times 7 factorial. And over here, this would be like 10 factorial over 7 factorial times 3 factorial. But it's the same numbers in the bottom. Can you guys see that? Let me give you one more. What if I gave you 12 choose 4? Tell me what that's going to be the same as. Okay, write that out on your paper. Okay, it should be the same as 12 choose 8, right? If I was doing that calculation, I would have 12 factorial over 4 factorial times 8 factorial. And over here would be 12 factorial over 8 factorial times 4 factorial, right? So the same numbers on the bottom, they're just flip-flopped. But if I multiply 2 times 4 or 4 times 2, that doesn't matter. It's still 8 either way. Right, so it doesn't matter the order we put them, it's the same package, it's the same product in the bottom. So I wanted you to see that relationship as well. All right, so then I said also that really what I want to ask is just F, right? I actually don't want to ask all those initial parts. I was just trying to build up to what we're going to get in F. So if I say, well, how many total sandwich creations are possible? Well, again, you know, our girl Lily, she could have no extra toppings or all of them or something in between. So really what you're ultimately doing is you're taking the 4 choose 0 and you're going to add it to 4 choose 1 and 4 choose 2 and 4 choose 3 and 4 choose 4, because she could have had none of these extra toppings or all of them or something in between. And I know that 4 choose 0 is 1, and so is 4 choose 4, right? Here's my numerical palindrome. I know that 4 choose 1 is going to be 4, and so is 4 choose 3. And then 4 choose 2 was 6. So if I add all of these up, I get 16 total sandwich creations. So 16 total options, right? Because we could have no toppings, we could have all the toppings, or something in between. Hi, Bo's little brother. That's very cute. All right, are we good to hear? Okay, so here, an example 4, straight out of the news. So this happened, I want to say about 10 years ago. So Wendy's went ahead and they printed thousands and thousands of bags, just like you see right here. And they were pretty sassy on their bags. They said, we figured out that there are 256 ways to personalize a Wendy's hamburger. Luckily, someone was paying attention in math class, right? So they're being really cocky. The unfortunate part is they were wrong. They did it wrong. It is not correct. So they wasted all this time and money, right, on this false claim where they were trying to be snarky and say like, oh, we're smarty pants, but they were actually wrong. So they got a lot of flack for it. They had to reprint all their packaging, but this is about 10 years ago. All right, so let me read through their claim. So Wendy's claims that there are 256 ways to personalize a hamburger. The different toppings that can be put on a hamburger at Wendy's are lettuce, tomatoes, red onions, pickles, mustard, ketchup, mayo, bacon, and cheese. So it's saying, okay, there are 9 toppings. Is this claim true? Why or why not? So I've already told you that it got shut down and hard. There were a lot of people who were like, actually, excuse me, I was paying attention in math class, and Wendy's, you're wrong. So let's show them why they're wrong. So if we have 9 toppings, right, we know that, well, you could choose none of those toppings, right? It could just be a plain old hamburger, no toppings whatsoever. Or anything in between up to all 9 of them. Right? You could have none of those extra toppings, you could have all 9 of those extra toppings, or something in between. So what does that look like? Right? It could be 9 choose 0 all the way up to 9 choose 9. So I'm just going to lay it out like this. Okay, so remember, this is going to be a numerical palindrome because of how they're going to pair up. So 9 choose 0 will be 1. If I'm choosing none of something or all of something, it can only happen one way. Okay, 9 choose 1. Well, if I'm choosing 1 of something, right, and I have 9 somethings, there are 9 ways that could happen. And 9 choose 1 is the same as 9 choose 8. So they're both 9, right? Again, it's like a numerical palindrome. All right, 9 choose 2. Let's practice in our calcs. So here I'm going to say 9, math, over to probability, and I want it to read combination right there, and I'm picking 2. So I should get 36. 9 choose 2 is 36. But that's going to be the same as 9 choose 7, also 36. Okay, one other thing I can do that goes faster in my calculator is I can retrieve my previous function that I have right here. So I can hit second and enter. So these two together, second enter, and it pulls up what I previously typed in, and then I can just type over it. So it can save you a little bit of time. So 9 choose 3 gets us 84, which is the same as 9 choose 6. They're both 84. And let me do that one more time. So I'm going to hit second enter, right? It pulls up what I typed in previously. I'm going to type over that and make it a 4. And it's going to give me 126, which is the same as 9 choose 5. Right? There's my numerical palindrome. So if I add these up, they add up to 512, not 256. So Wendy's thought they were being all sassy, right? Showing off. Someone was paying attention to math class, and they even sold themselves short, right? They gave half the actual amount of options, right? So that calculation that they did, they were really calculating with 8 toppings. This is what would have been true if it was 8 toppings, but not 9. I think Chipotle did something similar a couple of years ago where they were like, look at all the different combinations. And I think they also got shot down by someone who was actually paying attention in math class. All right. You guys have any questions for me here? Okay, so let's do a couple more and then we'll call it a day. Let's get my third sheet. All right, so example 5. Here we have a pizza shop. They offer 12 toppings. How many different 3-topping pizzas are possible? So I need to think for a moment. Does it matter the order that I pick those toppings, right? If I like ham, mushrooms, and olives, is that a different grouping than if I have olives, mushrooms, ham? No, it's the same grouping, right? So it's a combination. So this would be 12, choose 3. And I want you guys to type that into your calculator. Make sure you know the keystrokes. So go ahead, type it in. I'll do it one more time with you. Right, we're saying 12, math, over to probability, down to that third choice, and then 3, just like that. And we should get 220. Okay, if I was doing it longhand, I'd be saying 12 factorial over 12 minus 3 factorial, right? That's what it looks like as a permutation, but I got those duplicate groups of 3. So I have to divide out that 3 factorial as well. So 12 factorial over 3 factorial times 9 factorial. That ends up being 12 times 11 times 10 times 9 factorial over 3 times 2 times 1. It's writing out 3 factorial, and then times 9 factorial. So those 9 factorials, right, something over itself is just 1. And then if I look at the 12 and the 3, that can be a 4-to-1 ratio. And I still have that 2 in the bottom. So if I take the 10 and the 2, that's a 5-to-1 ratio. And if I multiply out the 4 times 11 times the 5, it gets me to 220 using my mechanics. So we should know how to do it by hand as well as in the calculator. All right, a couple more and then we're almost done. So example 6, we have 10 people who apply for a job. We have 2 situations. So decide which one is the permutation, which one is the combination. So how many ways can 4 of them be selected for a follow-up interview? That's scenario A. B, how many ways can 4 of them be scheduled for a follow-up interview? So that keyword, that key identifier for me comes in part B where it says scheduled. So if I'm scheduling, there's an order to that, right? There's an order to that. So if I have 10 people who are applying and I'm picking 4 for a follow-up interview, right? I have 10 who could be in that first slot, and then I'd have 9 that could be in that second slot, 8 in the third, 7 in the fourth, right? It's clear-cut permutation down here in B because order matters. There's an order to how we schedule. So in part B, this would be 10P4. And then up above an A, in how many ways can 4 of them be selected for a follow-up interview? Well, we're just picking a group of 4, right? And if that's A, B, C, and D, it doesn't matter which order I pull them, it's the same group of 4, right? If it's D, C, B, A, it's the same group of 4. So this would be your combination. So 10, choose 4. All right, so let me type them in. So combination, 10, math, probability, third choice, and I'm picking 4. So 10, C4, 10, choose 4. We say it both ways. So 2, 10 for the one on top. And on bottom, 10, math, over to probability. Now I'm saying P and 4. So more options for the permutations, because again, combination is a permutation where we divide out those duplicate groupings. So that first one was 210. And that second one was 5,040. All right, got 2 more. We slide on up. All right, here's my soul food example, because who doesn't love soul food? All right, we got Dahlia. Dahlia wants to order a chicken dinner from Soul Food. She has to make a selection for the amount of chicken pieces, right? She can pick 1, 2, or 3 pieces. Beans, right, can be red or black, and plantains can be garlic or sweet. So how many possible chicken dinners are available? Well, this one's a little bit different because she's picking from 3 different groups. She's picking from chicken, beans, and plantains. Okay, so with the chicken, right, there's really 3 options because she could pick 1, 2, or 3 pieces. So out of those 3 options, she's choosing 1. And then for the beans, out of those 2 options, she's choosing 1. And for the plantains, she's got 2 options and she's choosing 1. And what is so nice when it's something choosing 1, it ends up being the end value. So if I have 3 choices for chicken and I'm choosing 1, it's going to end up being 3. And then times 2 and another 2. So 3 times 2 times 2, we have 12 possible chicken dinners. So assuming we're not like subbing in the salads or adding extra pickled onions, because sometimes I do that. That's my favorite. But we're just picking from chicken, beans, plantains. We got 12 total possible chicken dinners. All right, got 1 more. All right, example 8. All right, we've got Ivy here. Ivy wants to read 4 books while on vacation. She loves biographies and novels. So just like before, we had 3 different pools to pick from, right? The chicken, the beans, the plantain options. Now we're saying biographies and novels. So I'm going to store that initially and just write, all right, here we're looking at biographies and novels. Okay. Well, she recently purchased 6 biographies and 4 novels. She wants to bring 3 biographies and 1 novel on vacation to read. How many different options are available? Okay, so I need to focus first on biographies. So she purchased 6 biographies. And we're looking at how many different groupings of 3 could she pick? Right? We know it's a combination because if she's picking book ABC, well, it's the same group as BCA, for example. So if I look at the 6 total, she's choosing 3. Okay, and then novels. So for the novels, she has 4 that she purchased, but she wants to bring 1. So out of the 4 available options, she's choosing exactly 1. And then we're going to multiply. So we need to know what is 6 choose 3. So here's 6, math, probability, combination. So 6 choose 3, and we get 20. So there's 20 different ways she could get a group of 3 biographies from that larger pool of 6. And then again, whenever it's choosing 1, it's going to be the n value. So 4 choose 1 is 4. So we multiply across 20 times 4, and we have 80 book options. Okay, so just to say it one more time, we spent a couple of days on the permutations, right? Because I thought it was really important to see the difference between a permutation and a combination. So spent a couple of days to really lay that groundwork in. And now as we transition to combinations, I hope you can see the distinction between the two. So a combination order no longer matters. We think of a combination as a permutation, but with duplicate groupings. So we're dividing out those duplicates just like the letters style of problem. The next layer that's going to come at us on Monday is we're going to look at combinations as probability problems. So what I'd like you guys to do is make sure that you practice these skills in a timely fashion. You have about 10 minutes left in class, so I'll give you some time to start your homework, but please have it done by Monday, because that next layer that comes Monday gets a little bit harder, because again, we're looking at probability questions instead. Okay? All right, so I'm going to stop my share. And